Hi and welcome to today's class. Today we're going to be talking about waves questions. Okay, so just like our previous video, we're going to do a little bit of answering questions and revising at the same time. Okay, so certain key aspects of this, I won't cover the entire chapter obviously, but I will cover all the questions that have been asked by the different trial papers. Okay, so if you have your stack of trial papers with you, it will be good for you to take them out. And I hope that at the end of this session, you will be able to get an idea of where you should focus on studying for your SPM exams. Okay, that's the point of all these holiday sessions. Okay, is to narrow down the focus to help you to study better. I'm not saying that you shouldn't study everything, you should study everything. But bila kamu semakin dekat kepada SPM kan, you want to make sure that you are studying the right things. Okay, and I hope this is a helpful session for you all. Okay, so here we have this question in Terengganu 2020. Okay, but before that, just to recap Okay, just to recap, there are altogether 4 wave phenomena. Okay, so 4 wave phenomenon. The first one, which is the simplest one, okay, is reflection. Okay, the second one is refraction. Okay, and the third one is diffraction, or some people like to say diffraction, which I think is just so nonsense. And the last one is interference. Okay, so reflection, refraction, diffraction, and interference. These are the 4 wave phenomena. 4 kejadian gelombang. Okay, ialah kejadian lah. Okay, these 4 things can happen to any wave, which includes light wave. Okay, so don't forget that in chapter 5 in form 4, okay, you learn actually reflection and refraction. Reflection, FL, is mirror, okay, cermin, and refraction, FR, is kanta, okay, kanta mata. But that is light lah. But when we talk about waves, okay, they extend it further to include the 2 extra wave phenomenon, which is diffraction and interference. And after an analysis of all the trial papers, I noticed that these 3 phenomena, okay, refraction, diffraction, and interference, are especially popular. Okay, and if you want to even focus it some more, okay, it's actually refraction and interference, even more popular. Okay, like the super popular questions are these 2 lah. Okay, refraction and interference. Now, another thing that we should know is that in the wave topic, actually like in the wave topic, there are only 2 formulas. Okay, number 1 is what we call the wave equation. The first equation is V equals to F lambda. Okay, velocity of the wave equals to frequency times the wavelength. The second formula, and the second formula actually is specific to interference only. Okay, the second formula only happens in interference, which is lambda equals to AX over D. So there are only 2 formulas actually in wave. Okay, but yeah lah, I know. There are some that, okay, some that insist lah, the third formula is F equals to 1 over T. Okay, which is 1 over 1 over period. Can lah, okay, if you want lah. But actually in all, to be fair lah, okay, to be fair, actually the, sorry, let me increase this a little bit higher. Okay, to be fair, V equals to F lambda and lambda equals to AX over D is the only one that matters, okay, in wave. Especially V equals to F lambda. Okay, this is a very popular formula, okay, that we will see soon enough. Okay, so diagram 2.1, Terengganu question number 2. Diagram 2.1 shows a phenomenon occurring along a beach. So there is a difference between the wavelength of area P and area Q. Okay, so you can see P over here, sorry, P over here, I don't know if you can see the mouse. P over here is the wavelength looks shorter, Okay, and then Q looks like bigger lah. Okay, so name the wave phenomenon shown in diagram 2.1. This is pembentukan teluk dan tanjung. The formation of bay and cape, okay, is refraction. Okay, refraction of waves. This is the wave phenomena. Remember, there are only four wave phenomena: reflection, refraction, diffraction, and interference. Okay, so let's remember that so that you don't get confused by the word. Sebab ini perkataan, this word always comes out. Okay, and you're supposed to name it only. Okay, so don't forget those four. Okay, what happens to the water wave energy when it is at the cape area? Okay, when it is at the cape area, okay, here the wave energy increases. Okay, kalau dia ada, so here at the cape area, the energy is high. The bay area, okay, the part where it's teluk, okay, the energy of the wave, okay, is low. That's why if you want to build a resort, okay, this is a popular question, resort, let's say you want to build a hotel or anything, you don't build it on the cape, you build it on the bay, because at the bay, the waves are, not so strong, so you can, you can play at the beach safely lah. Okay, in the cape, not only are the waves strong, okay, the rocks are also dangerous. Okay, there's a lot of rocks at the cape area. Okay, all right. Diagram 2.2 shows the plain water wave pattern. Okay, and I'm pretty sure that the question will ask us to draw. Okay, draw a line showing the normal at point R. Okay, so remember, normal is always perpendicular to the uh, border lah. Okay, I'm going to call this border, tapi sebenarnya it's called perpendicular to the plane lah. Okay, so this is the border. Okay, here is where the border is. Okay, sorry. Okay, so this is the border. So if this is the border at point R, okay, the normal line is always perpendicular, 90 darjah to this. So what you need to draw is take out your pembaris, okay, and draw a 90-degree line. You can draw it dotted line if you want. Okay, so that's the normal line. So by then you already answered question A. A line showing the normal at point R. Secondly, you need to draw the wave pattern after crossing point R in shallow water. So this is deep to shallow. Okay, deep to shallow. So deep to shallow, you need to think, is deep, deep water is less dense, okay, and shallow water is more dense. Okay, now let's remember again, L, M, N. Okay, L means if you're going from a less dense material to a more dense material, the wave is going to refract. Okay, refract nearer to normal. Remember this. Okay, if you're moving from less dense to more dense, okay, daripada deep to shallow, okay, then you can then you make sure that it is nearer. Another way to remember this, and this is also quite good lah, because he's always here kan, Dato Sri Najib. Okay, deep to shallow to nearer. Okay, you can also do that lah. Deep is shallow. Okay, nearer. Okay, Dato Sri Najib. Yeah, I know. If you want to do that lah. Okay, but I like to think of it as less dense, more dense, and nearer. But this one, less dense, more dense, nearer, usually is easier to remember kalau light. And kalau light, because light is, air is less dense. Contohnya, okay, so contohnya less dense is air. Apa ini? Sorry. Sorry, I don't know why you need to see that. Hold on. Okay. Let me pause the video first. Okay, so as I was saying just now, less dense is air. Usually more dense is like glass. Okay, so deep shallow water actually is less dense, more dense, but sometimes some people tend to forget your deep is less dense or more dense. Okay, deep is less dense. Okay, so less dense to more dense, the refraction it will move nearer. So if this is the normal, if this R line okay is moving at a certain angle, so it is going to move nearer towards the normal. Dia punya angle di sini akan jadi kecil. Okay, so once you have determined this is the path of the wave propagation, then you can draw the wavelength. Okay, so the two things you need to remember. Going from less dense to more dense, the or deep to shallow, okay, the wavelength becomes nearer to one another. So the first thing you must remember is that the wavelength cannot be the same as the deep side. So you have to draw it much, much more compact. Okay, like this. Okay, and then the direction must be almost actually almost identical to the this one lah. If you don't want it to be almost identical, also can. Okay, you can maybe draw it something like this. It doesn't have to be. It shouldn't be like actually. It shouldn't be the same direction as the plane. Okay, but this is where you get your 2 marks. Okay, so 1 mark is to show that it is moving nearer to normal. Okay, so the second one is the wavelength. Okay, the wavelength is shorter. This is the important one. Okay, so if you notice the deep side, okay, over here, the deep side, the wavelength is bigger. And then the shallow side, the wavelength is shorter. Okay, so that's pretty much the basics of refraction. Okay, as I said before, I'm covering, I'm doing ulang kaji and answering the questions at the same time. Okay, so I hope this helps you. All right. The next question is from Perlis. Okay, Perlis question number 4. Perlis question number 4. Hold on. Okay, so diagram 4.1 shows a type of wave. Okay, and then name this type of wave. This is a transverse wave. Okay, the opposite of transverse wave is longitudinal. Longitudinal wave. Okay, kalau ini transverse wave, longitudinal is like this. There is compression and then rarefaction. Compression and then rarefaction. Okay, just to highlight, so bahagian ini is compression. And then bahagian yang lenggang ini, okay, the one with a lot of spaces is rarefaction. Okay, so longitudinal waves look like that, and then the transverse wave is up and down, but it goes this one now. Okay, so the next one, underline the following statement. Vibration of medium for the wave is perpendicular, okay, to the direction of the wave propagation. Kalau parallel is longitudinal waves. Okay, but because this is a transverse wave, the vibration of medium for the wave is perpendicular, okay, to the direction of the wave propagation. Direction of wave propagation maksudnya gelombang ini bergerak, propagate ke arah sini. Tetapi dia punya the medium, the molecules, dia bergerak ke atas dan ke bawah. So if you have this, then it is transverse. Longitudinal, molecule bergerak ke kiri ke kanan, and the wave is moving this way. Okay, so that's why it's parallel, same direction. Okay, so that's the difference between longitudinal and transverse wave. All right. Here we have the same question again, okay, as in the Terengganu question 2. Okay, going from deep to shallow. So remember, Dato Sri Najib. Okay, so deep to shallow will be nearer to normal. The first thing you must do is, again, draw the normal line. Okay, no matter what, you need to draw the normal line. So if this is the plane, okay, and this is the point di mana dia, this one, since we are following this arrow lah, okay, we are following this line, Okay, so you have to draw a 90-degree line over here. Oh dear. Okay, something like this lah. Okay, if you have your ruler with you, it's better lah. Draw a 90-degree line. Now we know Datuk Sri Najib. So deep to shallow to nearer. So that means our wave is going to propagate this way. Okay, making a very small angle to this one. Kalau wave bergerak this way, then you can draw the wave pattern. Okay, the wave pattern will look like this. And don't forget that the wavelength must be smaller than the deep side. Okay, sini wavelength dia besar, sini wavelength dia kecil, because it's in shallow waters. Okay, so yeah, I hope this helps. So if you forget this, don't worry, think about the time you go to the beach. Okay, when you're at the beach, very far away, the waves are longer, like wider lah. But when it comes nearer and nearer to the shore, the wavelength is, so at far away like this, then nearer and nearer to the beach, you look like this. So the wavelength is actually smaller. Okay, don't forget that. So what happens to the velocity of the wave at the shallow region? Obviously, it will decrease lah. Okay, it will become slower, just like when the wave comes into the shore. Now, given that the velocity and the wavelength at the deep area is 100 centimeters per second, 40 centimeters respectively. Okay, so deep, okay, deep, the velocity is 100. The wavelength is 40. The good news is both are in cm. Okay, so no need to change anything. Okay, now shallow. Shallow, we are given that the wavelength is 20. Okay, now let's come back to this. Our formula is V equals to F lambda. Okay, F lambda. So in refraction, okay, this is the important thing. Okay, when refraction happens, okay, frequency is same, no matter where it is. Whether you're in the deep area or the shallow area, the frequency remains the same. So if you want to know what is the velocity at the shallow area, okay, you have to count first the frequency in the deep area, because I don't have enough information in the shallow. Okay, but I have enough to give me information about the deep area. So if deep is 100, velocity lambda wavelength is 40, V equals to F lambda, I can count F. Okay, F is equals to, oh, my calculator. What's 100 divided by 4? 100 divided by 40, 2.5. Should be 2.5. Okay, therefore, the frequency is 2.5. Because as I said before, okay, frequency in deep and shallow is the same. The only one that changes is the velocity and the wavelength. Okay, remember, deep wavelength is bigger. Sorry, deep wavelength is bigger, shallow wavelength is smaller. Okay, so V equals to F lambda. F equals to 2.5, lambda equals to 20. So my answer will be 50 centimeters per second. Follow the same unit. Okay, follow the same unit, 50 centimeters per second. So that means that the wavelength, since the wavelength is shorter, the speed, the wave speed also is smaller. Okay, from 100, very fast, okay, become 50, okay, half as fast as the original one. Okay, and notice that in this question, I only use one formula, which is V equals to F lambda. The only thing I have to know is that the V equals to F lambda in the deep side is one set. The V equals to F lambda on the shallow side is another set. The only thing that is the same is the frequency. Okay, the frequency of the waves. All right, next question comes from Kelantan. This is no longer refraction. This is barrier and, other gap di sini. So this is a diffraction question. Okay, so let's talk about diffraction a little bit lah. Okay, so what is the meaning of diffraction? Okay, diffraction is the spreading of waves after it passes through a gap or an obstacle. Okay, kalau ini, if you don't write or an obstacle, doesn't matter. Okay, the most important one is the gap. The most common one in our physics SPM is gap. Usually we talk about gap. We don't really talk about obstacle that much, but we always talk about gap. Okay, but the key word is the spreading of waves. The waves spread out. Okay, after it passes through the gap. Now, what happens to the wavelength of the water wave after passing through the narrow gap? Now, after passing through the narrow gap, what happens is to the wavelength is that it remains unchanged. Okay, this is the interesting thing. Nothing happens to the wavelength. It remains actually still the same wavelength, except that the energy is much less. Okay, it remains unchanged. All right, so diagram 3.2, sorry, hold on. Oh, okay. Right. Diagram 3.2 shows the wave pattern after passing through the barriers as the size of the gap is increased. Okay, now if the size of the gap is very small, like this, okay, after the wave comes here, okay, once it passes through the gap, it will look like this lah. It will look more circular, it will look more spread out, macam ni. Okay, this is the original, this one, right? Since the gap is very small, then it will break out much bigger. But if you increase the gap, okay, if you increase the gap, this wave over here on the left side is not going to feel so much of a difference because macam sama aja. So what happens is that there is still some spreading out lah. Okay, there is still some spreading out, but the wave will look like this, not very spread out lah. Okay, like sikit saja, almost straight. Okay, if you want. Okay, two things to note here. This is probably 2 marks, I think. Oh, the number of marks is not here. This is 2 marks. Okay. Now this is 2 marks because number one, of course, 1 mark is for the shape of the wave lah. Okay, it should look like a very kotak-kotak-ish lah. Okay, berbanding dengan kalau dia punya gap is very small. If the gap is very small, then you want circular wavefronts. Okay, but since the gap is so big, there is hardly an effect. So the way we show hardly an effect is by drawing like kotak-kotak punya wave lah. It doesn't really, actually it is lah kotak-kotak, but it happens so fast that you don't really see it unless you use a stroboscope lah. Okay, the second mark is the wavelength. Okay, must be said. And this is the tough part. Okay, because now you have to really see okay, how long is this, and then you have to make sure that it's about the same. Okay, don't worry lah, the examiner's not going to take a pembaris and then okay, measure, no lah, but it has to look about the same. Okay, it cannot be okay, it cannot be, let's say this is the barrier, then you draw like that, very near to one another. Ni salah lah. Okay, you only get 1 mark. For the shape, you will get correct. But since the wavelength is so near to one another, it is not like this section over here, okay, then you will lose the second mark. So be very careful. Remember, refraction, wavelength changes. Diffraction, wavelength doesn't change. Okay, be very careful with that. Okay, calculate the wavelength of the incoming water if the velocity is 50, wave frequency is 23. This is basically a bonus question. V equals to F lambda is the only formula, okay, unless you're talking about interference. Okay, interference, lain cerita sikit lah, they will combine both formulas. Wave frequency is F, velocity is V. What do you have to count? Lambda. There's really nothing to this. Okay, if you know the formula, this is 2 easy marks. Okay, V equals to F lambda, 50 equals to 23 times lambda. Okay, and you will get lambda equals to 2.17. Just make sure that your unit follows the wave, the velocity. Okay, kalau dia meter, meter. Remember the Perlis question just now when we were the Perlis question just now? The Perlis question just now we're using centimeter. because the unit given in the question is centimeter per second. Okay, so that's about the only thing that they will change, whether you use meter or whether you use centimeter. But the formula remains the same. Okay, commit this formula to memory. Okay, ingat formula ini sebab dalam gelombang hanya ada dua saja formula. Okay, fine, 2,5 lah. F equals to 1 over T. Ini sebenarnya bukan formula, ini logic saja ini. Okay, F equals to 1 over T if you want. But there's two formulas you have to remember. The first one is the most important one. We call it the wave equation. V equals to F lambda. Okay, be very careful with this. All right, next question comes from Penang. This is also a diffraction question. Okay, because there is a obstacle lah. Tapi ini bukan gap, ini adalah obstacle. Yeah, okay. So diagram 6.1, okay, shows a water wave passing through a log that floats on water. Hold on. Oh, okay. That floats on water. Okay. Diagram 6.2, okay, shows a student standing at one corner of the building B, okay, who can hear the sound of the loudspeaker at position A. So the loudspeaker is here, the student is here. He can't see the speaker. Maybe from our point of view, it looks like he can, but actually he can't. Okay, he can't see the speaker, but he can hear the sound of the speaker. This is an application of diffraction. Okay, so all this now is diffraction. Okay, so when dealing with waves now, it's always good to know, kamu mesti set dalam kepala dulu lah. Okay, what is the phenomena we're talking about? Usually dalam soalan, dia tidak akan tanya dua phenomena in the same question, especially structured lah. Okay, kalau soalan essay dia mungkin akan tanya, tapi usually in structure, they will only focus on one phenomenon. So it's always good to know, okay, what phenomena is this? Is this refraction? Is this diffraction? Is this reflection? Is this interference? But in this case, this is diffraction. So even if you don't know what is this kan, you know that this is an obstacle. Ini adalah halangan. Okay, the rock is a halangan, so the wave will be macam tu. Okay, akan tersebar. So, based on diagram 6.1 and 6.2, what happens to the wave after passing around the log and the corner of the building? Okay, the wave is diffracted. Okay, it's as simple. Notice that they are asking the same question in a different way. Okay, usually the first question is, what is, name this phenomenon? Okay, name this phenomenon. Okay, and then students will just say, oh, diffraction of waves, begitu. But they're asking the same thing, cuma dia tukar dia punya bentuk soalan. Okay, what happens to the wave? The wave is diffracted. If you want to make your answer a little bit better, you can say the wave spreads out. Because that's the meaning of diffraction. Okay, the spreading of waves after it passes through a gap or or an obstacle lah. Okay, in this case, this is obstacle lah. Sebab the wall is an obstacle, the log, okay, this log, kayu balak, is an obstacle. Okay, so the wave spreads out. So they're actually asking the same thing. What is this phenomenon? Cuma dia ubah saja. Okay, dia ubah saja dia punya bentuk soalan. What happens to the amplitude of the waves? Okay, after passing this one, explain your answer. So you have 2 marks lah. Okay, so the amplitude of the waves, amplitude decreases. Okay, because wave energy okay, decreases. Okay, that's where you get the 2 marks. So the first one is you tell me what happens to the amplitude. Okay, and amplitude always has to do with the energy of the wave. So the energy of the wave decrease, so that's why the amplitude decreases. Okay, name the wave phenomenon. Finally, they tell you to name the wave phenomenon, and this is a bonus question because you've actually already answered in the first question. Okay, the wave diffraction. What will happen to the speed of the water waves, okay, after passing through the log? Okay, the speed of the water waves remains unchanged. Okay, and this is where usually students will start to be confused lah. Kenapa ini diffraction kan dia punya unchanged line, refraction dia punya unchanged line. Okay, so I'm just going to lay down here. So benda yang menjadi unchanged, okay, alamak. Okay, kalau refraction, okay, is frequency. Okay, in refraction, the frequency remains unchanged. Okay, the F is the same. In diffraction, okay, a lot of things doesn't change. Okay, the speed doesn't change. Okay, the wavelength also doesn't change. Yeah, banyak benda dah berubah. Okay, and actually the frequency also doesn't change now. Just the energy saja yang berubah. Okay, the amplitude changes. Okay, so speed doesn't change, wavelength doesn't change. Actually, frequency also doesn't change. Okay, but for refraction now, only frequency is unchanged. Okay, so I hope this helps you to remember. Okay, this is basically a bonus question. The speed actually remains unchanged. Okay, because everything, only amplitude and energy, okay, is changed in diffraction. Okay, because you change the, because you spread out the waves. Okay, you spread out the wave energy. All right, referring to diagram 6.1, what will happen to the floating object that is placed at P? Okay, so if you put a floating object here, okay, at P, and if you put the floating object at Q, okay, what will happen? Okay, so if you put a floating object at P, okay, since there is a wave over here, okay, so the P side, it will oscillate because there is waves over there. But at Q, if you place an object here at Q, since there is no wave over here, okay, since this wave has been somehow diffracted, okay, then Q will be stationary. Okay, it will not move now. Okay, name one other wave phenomenon that occurs in diagram 6.1. Okay, so in this diagram, okay, besides diffraction, okay, the wave pass through here, then it will be like spread out now. Okay, the wave will also be reflected back. Okay, so it will be reflection. Okay. Okay, now we come to Negeri Sembilan question 8. Okay, and this is where I'm going to start to go into the section B and section C question. Okay, so one of the popular questions that seem to be asked in a lot of trial papers is about satellite. Okay, this seems to be a very popular question, which is also, you can find the answer in the black book. Okay, so it'll be good to dog ear the satellite page, okay, and try to memorize this one. As we answer also, you will get it. Okay, so diagram 8.1 shows a remote controller. State the waves emitted by the remote controller. Remote control is infrared. Okay, infrared waves. Okay, now diagram 8.2 shows a transmitting station for telecommunications. 8.3 shows the X-ray. Now, based on 8.2 and 8.3, what is the two common characteristics between the waves used? Now, this telecommunication is either radio wave or it's microwave lah. Okay, this is obviously X-ray, but all this come under the same family of waves, which is the electromagnetic waves. Okay, so we have to give two common characteristics between in electromagnetic waves. There are many characteristics lah, okay, of electromagnetic waves, but I'm just going to say two lah. Number one, it travels at a speed of light. At the speed of light, sorry. At the speed of light in a vacuum. Okay, ini number one. Number two, it is a transverse wave. Okay, there are at least 5 characteristics of electromagnetic waves. Okay, go and research. Okay, go and do a little bit of research. Don't just memorize two and this one. Why did the question ask you to give all 5? Okay, so go and go and do a little bit of research on electromagnetic waves, because this seems to be a very popular question this year. Okay, for your trial, for the trial exams lah. Okay, so travels at the speed of light in a vacuum. It is a transverse wave. Talk about the velocity. Talk about, dia ada banyak ciri. Okay, there are a lot of characteristics in electromagnetic waves. So it'll be a good idea for you to go and just, research it and write out the full answer. But I'll just give you the two over here for now. Okay, question number 2. Diagram shows a satellite disk detect a signal transmitted from a broadcasting station through a satellite that is located 35,000 kilometers from the Earth. Okay, so you have this distance somewhere over here. Now, if the time taken by the waves to be reflected back to the receiver is 2 nanoseconds, okay, 2 nanoseconds. So ns is nano. Okay, nano is times 10 to the power of negative 9. Okay, calculate the focal length of the disk. Now this probably is okay, fine lah. This I know I mentioned just now that there are only 2 formulas you need, okay, in this one. And I still maintain that because this one, D equals to VT over 2, okay, sebenarnya you can actually derive this formula. Okay, but okay, fine. If you don't want, then you memorize lah the 4th formula in this, 3rd or 4th, depending on where your position is on the frequency formula. So distance equals to velocity times time over 2. So the distance is given as 35,000. Okay, sorry. No. Focal length of the disk. Oh, hold on. Okay, so velocity, velocity of the wave is 3 times 10 to the power of 8, okay, meters per second, because all electromagnetic waves move at the speed of light, which is 3 times 10 to the power of 8. Okay, then since the time taken, okay, is 2 nanoseconds, okay, therefore, if you want to calculate this, so it will be V, what's the formula? D equals to VT over 2. Okay. D equals to VT over 2. Hold on. There seems to be something strange about this question. Just give me 1 minute to think about this. Okay, so there's a slight strangeness to this question now. Okay, so there is a 35,000 kilometer, okay, that is given here. So the satellite is 35,000 kilometers over there lah. Okay, but wait, hold on. I need to check this again. Okay, you know what? I will post this answer. Let me figure out this answer first, because I'm looking at the marking scheme kan, tapi macam ada something wrong with the marking scheme. So let me go through this. I will post up the answer to this in your various groups. Okay, and then if you have any questions about this question, we will talk about this lah. Okay, but let's move on to another question for now, which is the main one I want to talk about. Okay, so this table shows 3 radar system disks, okay, which can be used to control aeroplanes in air traffic. Okay, so these are very common characteristics. Ini making decision punya question lah. So you got 3 types of this, but you're only given 3 characteristics because this is not a section C question. Okay, so the first one is orientation of this. Does this okay be able to rotate or no rotate? Okay, so obviously you want it to be rotating lah, because this is for airplane. Okay, it's not for TV signal. TV signal should be one direction. Okay, but airplane you want to be able to detect all the planes that are coming in from every area. Okay, so dia mesti dapat berputar 360 darjah. The diameter of the disc, should it be big or should it be small? It should be big lah. Okay, because the bigger your disc, okay, then the more waves you can receive. Secondly, the location of the disc, should it be high on the mountain or low on the ground? Any pilot will tell you that the disc, the receiver should be somewhere high. So, bila kamu buat ini, kamu tahu sudah, okay, L is the best choice. Okay, so let's talk about this. So the orientation of the disc, okay, is, what is it? We're talking rotate 360, right? Okay, so rotate 360. Okay, 360 degrees. So to be able to transmit and receive wave signals, okay, from many directions. Okay, the diameter of the disc should be big. Dia tulis apa? Big or small? Bukan. Okay, the diameter is big to receive more wave transmission. Okay, that's another one. Okay, location of the disc should be high. Okay, so to avoid waves from reflecting, okay, or diffracting, okay, on an obstacle. Bila dia berjumpa dengan satu halangan, obstacle, because if you put it low, kan, there's mountains, there's trees, so it's going to be a lot of reflecting, diffracting, refracting. So we don't want that. Okay, so we want to avoid, we put the waves in a high ground, so it's almost direct contact, okay, with the plane. So based on our answers, determine the most suitable. The most suitable is this L. Okay, now just to remind you, question 8, usually they won't ask you to give the reason. Is in section C yang kamu kena bagi reason. Okay, but the reason why I want to talk about this question is because this question comes out in what question is this? Negeri Sembilan. Okay, this Negeri Sembilan question 8. The satellites question comes out again in Kelantan question number 12. Let's take a look at Kelantan question number 12. See, over here again. Okay, slightly different. Okay, slightly different, but let's talk about this question. So we want to determine the characteristics of the ABA, of the parabolic disc here. Okay, we want to state the suitable characteristics of the parabolic disc. Let's take a look here. So this is for satellite TV. So slightly different. Just now was airplane. But this is for satellite TV. But the point is still the same. We want to receive the wave signal effectively. Okay, so which one will we use? Do we use high or low frequency? Hold on. This is what? This is what? Kelantan. Kelantan. Okay, we want to have high wave energy and high frequency. Okay, we want to have high wave energy and high frequency. Okay, so that it is easy to reflect. Okay, easy to reflect, easy to diffract. No, it doesn't lose energy lah. Okay, because whenever waves move, whenever waves propagate, they will lose energy along the way. So we want it to be transmitting with high energy, so that by the time it reaches the TV, kan dia tidak akan kehilangan that much energy or frequency. Okay, So we want it, do we want it to be high diffraction or low diffraction? Okay, we want it to be high diffraction. Okay, high diffraction so that it can pass through obstacles easily. Okay, that's the reason for high diffraction. Kalau dia kurang mampu untuk diffractkan, when it hits the mountain lah, okay, or the tree lah, then it will just stop there. Okay, because there's not enough energy lah, okay, to diffract. Distance between the signal receiver and the parabolic disc. So we're talking about this one, this distance, okay, and the disc over here. Okay, this distance. Do we want the distance to be far, or do we want to be distance that's near? Okay, or do we, in this case, same as focal length or less than focal length? Which one do we want? Okay, we want it to be the same as the focal length because this is the law of reflection. Huh? Okay, remember if this is a mirror, okay, remember concave mirror, bahkan if light hits here, there, sorry, if this is the principal axis, okay, this is the focal point. The focal point, the focal length is where the light focuses. Okay, so if you have a light coming here, once it reflects, it will reflect over here. Okay, it will be here. So if the position of your signal receiver and the parabolic disc should be ngam-ngam at the focal length of the parabolic disc. Okay, parabolic disc, they're piring makan, so it looks like a mirror lah. Okay, so we want it to be same as the focal length. Okay, so that, okay, this one, the reason is so that the reflection is fully, the wave reflection okay, is fully focused on the receiver. Kalau the receiver is less than the focal length, bukan semua akan fully focus. And that's bad lah, because we want the signal to come into the satellite fully focused on the receiver. Okay. Last part, diameter of the parabolic disc. This is the same question as just now. The diameter should be big. Okay, and the same reason as just now. You remember? Okay, to receive more wave signals. Okay, if you have ever been to a signal transmission station, okay, you will see that the disc, the parabolic disc, okay, the mangkok, okay, is very huge. Okay, it's not like our astro, it's not like our astro satellite dish, which is so tiny in comparison. Okay, the one at the broadcasting station is huge. You know, we're talking about the size of a house or a field. Okay, it's very big, and there are many dishes. Okay, many discs. Okay, many parabolic discs. Kalau kamu pernah pergi ke broadcasting station. Okay, so very important. Okay, that it should be big. So after doing the analysis of the table, you notice that the best parabolic disc is Q. Okay, then kenapa Q? Well, the same question again lah. Okay, sorry, don't forget to give the same reasons. Okay, for the 10 marks. Let me see. Okay, what is meant by transverse waves? I should cover. Explain how the position of the aeroplane can be determined. Okay, this one, the answer is actually in the black book. Okay, so please refer to the black book to answer this. I think the last one is this one. Okay, so this question, this one is use V equals to F lambda to determine the wavelength. Okay, you want to find wavelength. And then after that, this one you use D equals to VT over 2. But don't forget that the millisecond. Okay, so 50 milliseconds is equals to 50 times 10 to the power of -3. Okay, seconds. So make sure you change it to seconds. Okay, whenever you use this formula. Okay, I'll just give you the answer here. Lambda equals to 0.0125 meters. Okay, here V equals to, sorry, D, distance bahkan. Distance equals to 37.5 meters. Okay, give that a try, use this formula. Another thing you need to take note is 120 kilohertz. 120 kilohertz, it has to be 120 times 10 to the power of 3. Okay, hertz. So kilo is 10 to the power of 3, milli, okay, is 10 to the power of negative 3. Okay. The question just now that I skipped. Okay, I will show you the solution a bit later. I just need to figure out there's something off with this question, so I need to figure it out in a while. Okay, now the same question, satellite, is asked again in Malacca. Okay, Malacca 2020, but the concept before that is slightly different. Okay, let's take a look at this. So same thing, aeroplane, parabolic disc, blah, blah, blah. So diameter, in this case, they are giving you numbers, 10, 3, 9, and 5. Okay, we never write numbers in our answer. What do we write? We write the diameter of the parabolic dish should be big. Okay, we please never write the number. Okay, I know they give the number, but never write the number. Okay, so in your mind, you are thinking either 10 or 9. So ini yang besar. Okay, 10 meters. I think this is very long. No, my hands is only about 1.7 meters. Okay, so 10 meters is like 5 times longer than me. Okay, so 10 or 9. Okay, that's the diameter of the parabolic. So we want it big for the reasons that I said just now. You can receive more signals. Okay, type of wave transmitted. You want it to be microwave or radio wave. Okay, obviously we want it to be microwave lah. Okay, microwave is high energy. Yeah. Okay, so I'm going to write down here. Microwave is high energy or high frequency. Either one of these is an acceptable answer. Give both. Okay, if you know both, then give both. Notice that in this question, they ask you to determine the type of wave because it's high energy or high frequency. In the question before this, in Kelantan, they ask you to determine whether the frequency in the waves is high and then give the reason why. So it's slightly different. Okay, I mean same thing, tapi dia cara dia tanya adalah berlainan. If they ask you whether you want radio wave or microwave, you choose microwave because it is high frequency, high energy. But if they ask you to choose between high frequency and low wave, high or low wave frequency and energy, you choose high because it is easy to reflect, it's easy to diffract. Okay, ada banyak sebab lah. Okay, so be very careful with this now. Okay, can I write microwave that is easy to reflect? Can, because it pretty much gives the same meaning. Okay, but this is obviously a better answer. High energy, high frequency. Distance from the signal receiver from the parabolic dish. Same thing as just now. Okay, the signal receiver is here. This is the parabolic dish. So what should this distance be? Should it be the focal length or less than the focal length? Obviously, we want focal length. Okay, for the same reasons as just now. Okay, next, height of the parabolic dish. Do we want the parabolic dish to be high or low? We want it to be high. Okay, macam biasalah, we want the parabolic dish to be high so that dia akan mengurangkan halangan. Okay, less obstacles. Okay, or less blockage. Blockage sounds so wrong. Tapi boleh lah. Okay, kurang halangan lah. Okay, so after you've done this analysis, you notice that R yang terbaik. Because, okay, because the diameter is big. Never say the diameter is 9. Okay, be very careful. Saya akan cakap ni balik-balik ni. Jangan guna nombor. Okay, when we are doing a decision-making question. Always use high, low, big, small, greater, lower. Okay, never use the number. Although they give the number, don't use the number. Okay, that's a pretty standard answering technique. Okay, so be very careful. Okay, just to come back this one, what is the meaning of frequency? Frequency is a number of oscillations per second. Okay, explain how resonance occurs, refer to the black book. Okay, I won't talk about this. And then the last question is the same thing lah. Okay, the calculation questions, which also only use the same two formulas. Okay, this one is D equals to VT over 2. This one is V equals to F lambda. Okay, so you notice after a while, the pattern of the question is the same lah. Okay, take a look at the unit for frequency, 25 kilohertz. I said just now 25, you need to change to times 10 to the power of 3. The good news is our time is in seconds, so no need to do anything. Just now the question, the time was in milliseconds. Okay, so be very careful here. So this one, the answer according to this scheme is 90 meters. Here is 0.06 meters wavelength. Okay, so give it a shot. Okay, give these questions a try. Okay, and you know, if you have any problems, you can always ask me. Okay, another question. Okay, that I don't think this one involves no, it involves satellite, but slightly different lah. Okay, Putrajaya question 12. Okay, Putrajaya question 12. Okay, so Fahim, I want to talk about this question first. Fahim Entertainment, okay, wants to install a new communication system, okay, for digital broadcasting system. So macam sama dengan tadi lah yang satellite. Okay, sistem komunikasi bagi melancarkan siaran digital. So we're talking about parabolic, maybe parabolic dish, I don't know. So based on table 12, choose the best system of communication satellite and station on the Earth. Okay, so type of system. So looks like the same question, right? Do we want microwave, radio wave, infrared, and ultraviolet? Wow, this is a not very good question. So dia punya pilihan 4. Kalau kau sudah pilih satu kan, itulah itu kan jawapannya. Okay, obviously we want microwaves. Okay, microwaves, and the reason is high energy, high frequency, same as just now. Okay, frequency of the waves. Do we want high or low? 9, 3, -7, -4. Of course, we want high. Okay, guys, again, never write the number. Frequency of the waves is high so that it is, you know, easy to reflect. Okay, blah blah blah. Easy to reflect, easy to diffract. Okay, begitu. Diameter of the receiver, same thing. Diameter of the dish should be big. Okay, sorry, this is high, right? So 10 to the power of 9 is pretty high lah. Okay, location of the transmitter and the receiver. Okay, di mana dia punya dish? Do we want it to be high or low? After 2 questions, this should be very easy. So the best system obviously is X. Okay, so same question, just dia tanya dalam bentuk yang berlainan. Okay, but if you know the concept of satellites, like you know the use of satellites well enough, okay, this question should be no problem. Refer to the black book. Okay, tengok buku hitam kamu, look for the satellite page. Okay, dot mark it atau salin balik. Okay, copy back the thing so you remember, and it'll be easy for you to. It will be easy. What am I saying? It'll be easy for you to revise, especially when you are just before paper 2, when you just want to belik something. That's the thing that you should belik. You shouldn't be taking out all these trial papers anymore. Okay, at that time. Okay, let me just go back here. So what type of wave is C wave? C wave is transverse lah. Okay. C waves is transverse wave, right? Yeah, transverse. Transverse is the one that goes up and down. Longitude, yeah, okay. So explain the suitable characteristic to build a new jetty. It's interesting, huh? Okay, you want to build a new jetty. Okay, you build it at Cape. Okay, high retaining wall. This one also high retaining wall. All this can be found in the black book. Okay, this is probably also a good question to just do a short revision. Let's say you want to build a new jetty or a hotel. Okay, talk about a cape. Remember just now we talked cape or bay. Okay, bay, cape. Sorry, terbalik. Bay, cape. This is cape. This is cape. Am I right? Sorry. Let me take a look at the diagram this time. Oh yeah. Oh, the cape is the top. Okay, so build at the bay. Oh no, sorry. Sorry. Build at the bay. Okay. Okay, so here is the bay. Here is the cape. Okay, so build at the bay, high retaining wall, all these are in the black book. Okay, the last question, sorry, this question is also calculation question. Okay, so deep to shallow, remember Dato Sri Najib. So first thing is, since the wave front and the border is the same, so there is not that much refraction. Dia akan berubah arah, cuma apa yang berubah kalau refraction, dia punya wavelength. So it will be nearer to one another. So as long as you can draw it nearer to one another, you get the 2 mark. Okay. Deep to shallow, it will be near, but this one, it doesn't change direction because it is same direction as the normal. Okay, speed of the water waves is this. Calculate the frequency, same thing, V equals to F lambda. I think you are given lambda. Okay, the wavelength is 20 millimeters. Okay, once again, milli, 20 times 10 to the power of -3. Be very careful. Okay, lambda, make sure you change it to meters. Determine the frequency of the water waves as it enters the shallow region. It is the same frequency. Okay, so the answer for number 2 is 1500 hertz, which is the same as answer number 3, 1500 hertz. Okay, because in refraction, okay, F is the same. Be careful with this. Okay, that's why it's only 1 mark, because dia ada pengiraan. Tinggal kau beri jawapan saja. Okay, all you have to do is understand that the frequency in shallow region is the same as deep region. Okay. Yes, so we are coming to this one. Okay, we are coming to this question, and this is a different concept altogether. Okay, so we've talked about refraction, we've talked about diffraction. Now we have to talk about interference. Okay, interference, the main formula is lambda equals to AX over D. Okay, I'm going to show you this ripple tank, this one, just to remind you where is A and where is D. Where is A, where is X, where is D. Wavelength is wavelength. Okay, distance between 2 crests or 2 troughs. A is the distance between the 2 dippers. So this is A. Okay. D is the distance between the 2 sources until the place where you are measuring. So this is D. Okay. X is the distance between one antinode to the next antinode. So this is X. Okay, or one node to the next node now. Okay, so just to remind you, what is node and antinode? Antinode is where constructive interference happens. Node is where destructive interference happens. Now, constructive interference is crest plus crest or trough plus trough. Okay, ini tambah ini atau ini tambah ini. That's constructive interference. It will become twice as big lah. Dia akan jadi lebih besar. Destructive interference is crest plus trough. Then it will become 0 flat. Okay, so all these dotted lines are destructive interference. Okay, so that's interference in a nutshell. Okay, just secara ulang kaji sajalah. What is the wave phenomenon? Okay, it's interference. This is Putrajaya number 7. This is interference. I don't think you need to write the words constructive or destructive. Okay, so what will happen to the distance between the two consecutive antinodal lines? This is X. Apa yang akan terjadi kepada X when the distance between the dippers, which is A, okay, is decreased? Okay, take a look at the formula. Formula is lambda equals to AX over D. Okay, now kalau kau tengok formula ini susah mau tengok. Okay, so I'm going to move the X and the D across lah. So lambda D over X equals to A. We find that when A decreases, X will increase. Sebab dia adalah inversely proportional. Okay, take a look at the position in the formula. X di bawah, A di atas. Okay, so when A is decreased, X will increase. Okay, I don't know why they give two lines just to answer one word, which is increase. Okay, the two consecutive antinodal lines will increase. Now, one thing I have to say about this question now is that this is a very popular question because ramai murid, okay, a lot of students, they will know what is A, what is X, and what is D in their own language or dalam fahaman sendiri. Or A is this distance, X is this distance, D is this distance. Tapi when the question comes out now dalam full sentence macam ni, what will happen to the distance between the two consecutive antinodal lines when the distance between the dippers is decreased? Okay, terus macam apa ini? Okay, because you don't commit this to memory. Okay, so you have to know what is X, what is A, what is D in the actual definition. Because look at the answer. The answer is one word and it's one free mark, if you understand what the question is. Okay, jarak di antara dua garis antinod. The distance between two consecutive antinodal lines is X. Distance between the dippers. Distance between the speakers. Kalau ini adalah sound wave, okay, I put the speaker over here and speaker over here. Same thing is A. Okay, this is a very popular question. Soalan yang sangat popular. Popular in paper 1, popular in paper 2. But if you don't know what the words mean, okay, then kamu rugi. Okay, so take some time, to sit down and understand what is A, what is X, and what is D, and commit it into memory. Okay, so that you don't lose out on this mark. Because saya rasa sayang, kalau kerana bahasa kan terus kau kantoi. Janganlah. Okay, bukannya susah mau hafal pun, kan? Okay, but a small piece of cork is placed at point P. Okay, so point P is over here. This is constructive interference. Okay, so state the motion of the cork. Will the cork move up and down or will the cork remain stationary? So, obviously, the cork will oscillate. Sorry, the cork. Cork is gabus. Gabus is the thing that you tutup wine bottles with. Okay, up and down. Okay, if you want to make your answer better, you can say with a large amplitude. Okay, explain your answer. Why? Because at point P, constructive, okay, interference occurs. OCCURS. Okay, at point P, constructive interference occurs, which is why we get this one. So, macam mana kalau dia destructive interference? Okay, so destructive interference, I'm going to use blue color. So, destructive interference happens here. Bila ada crest dan trough berjumpa. Okay, here, semua ni lah. Okay, ini destructive interference. Now, kalau constructive interference, up plus up will be 2 up, or this one will be 2 down. Okay, dia akan amplitude dia sangat besar. But destructive interference, okay, kalau destructive interference, then your answer will be the cork will be stationary. Okay, this is not jawapan for C1. I'm just showing the answer if it is a destructive interference punya tempat. Okay, if it is at these points lah. Okay, the ones where are destructive interference. So the cork will be stationary, and then your answer will be destructive interference occurs. Okay, sebab the two waves will cancel each other out at that point, pada ketika itu. Okay, so there will be destructive interference. Now the depth of the water is increased. Okay, kita tinggikan kedalaman. What will happen to the distance between the two consecutive antinodal lines? Okay. So this is how it will be. The distance between two consecutive antinodal lines is x. Apa yang akan berlaku kepada x sekiranya the depth of the water is increased? Okay. Number one, the distance will be increased. Okay, you will find that in deep water, this distance, okay, this distance over here will be even bigger. Okay, number one, the distance increased because the speed increased. Okay, and number three, the wavelength increase. Now, doesn't this sound very familiar? Okay, we talked about this in refraction. Remember, when the depth of the water is increased at deep water, okay, pada deep water, okay, deep water, okay, wave speed increases, wavelength also is increases. That's why the distance also increases, the x distance increases, because kalau wavelength is increased, remember the interference formula? Sorry. Interference formula is lambda equals to AX over D. If my lambda increase because I'm in deep water, okay, so my X will also increase. Okay, so this is the thing. So 3 marks, 1 mark here, 1 mark here, 1 mark here. The distance between two consecutive antinodal lines will increase because the wave speed increases, therefore the wavelength increases. Okay, that's why this is 3 mark question. Okay, this is actually a good question. You know why? Because in this question, everything in interference is covered. Yeah, so I'm like, oh, okay. Good job, Putrajaya, for this question. There was one question just now, the Putrajaya one is totally hopeless, but this question is very good. Okay, because I can revise interference all at once in this question. Okay, diagram 7.2 shows the lecture hall at a university. This is a very standard question. Always lecture hall and always students. Okay, so students suggest that some improvements need to be made to the sound system. Suggest a suitable arrangement of the speakers so that the sound can be heard clearly throughout the hall. So, kamu ada susunan P, Q, R, S, and only 2 choices. Position of the speakers, in front of the microphone or behind the microphone. Okay, if you've ever worked with microphone, if your microphone is in front of the speaker, okay, then memang maut. Okay, so we want the speakers to be in front of the microphones. Okay, and the reason, oh, sorry, we should write it lah. Okay, in front, okay, of the microphone. Okay, to avoid disturbance. Sorry. Okay, to feed, or what we call feedback lah. Okay. Feedback is, I'm not sure if you've done this, but kalau kamu cukup karaoke kan, kamu akan tahu ini. If you put the microphone in front of the speaker, you will hear the wheek sound, very, very high pitch, high frequency sound. That is what we call feedback lah. Okay, but in physics now we call this disturbance. Okay, mengganggu, because it's really annoying, you know, put a microphone in front of the speaker. Okay, so we want to avoid this feedback. So that's why we always put the speaker and then you stand behind the speaker and you talk. Okay, so that you don't get feedback. Okay, feedback is apa tau. So the microphone's job is to, whatever sound that goes into the microphone will be made louder. So let's say you're standing in front of the speaker, you are talking, and then the speaker is behind you. So the microphone is going to pick up two kinds of sound. It's going to pick up your voice, and it's going to pick up the sound of the speaker, and that causes a feedback. That causes a disturbance, which causes the high pitch sound. Okay, so yeah, so that's why we put the speaker in front of the microphone. The distance between the speakers. Okay, so does it need to be near to one another, or does it need to be further from one another? So think about it. Lambda equals to AX over D. If you want more people to hear, okay, if you want more people to hear, you want the X to be low. Okay, the distance between the antinodal lines should be nearer to one another. So if you want the X to be low, the A should be high. So therefore, you want further from each other. Okay, you want it further from each other. So further distance between the speakers, so that sorry. Okay, so this answer that they give over here is quite nice lah. Okay, so that the position of constructive and destructive interference are closer to one another until they are hardly noticeable. When the constructive and destructive interference are so near to one another, then because they're so near to one another, then they become hardly noticeable. Susah mau bezakan mana constructive mana destructive. If your distance between, if your X is very big, means very obvious sini constructive, very obvious sini destructive kan. Kesianlah yang destructive itu. Tidak, dia kurang kedengaran. Okay. But if your constructive and destructive are very near to one another, then the destructive kan dia akan dapat tumpang tumpang the constructive from next door. Which is why in the hall, I can't remember our hall already. So in the hall, you notice that usually they put the speakers as far away as possible from one another to reduce the distance between the different constructive interference. Okay, so this is actually a very good answer. Okay, very cantik, but I think this answer. Okay, positions of constructive and destructive interference are closer to one another until they are hardly noticeable. Okay, so this interference question seems to come only in Terengganu 2020. Okay, and in section B. So kalau kamu notice sebelum ini kan, the hotter question seems to be the satellite question lah. Okay, tapi ada juga ini soalan. And the reason why I want to highlight this is because last year, okay, last year SPM, okay, kalau saya tidak silap lah, I think I'm not wrong. Last year SPM, sorry, last year SPM, the question that came out actually was on electromagnetic waves. So which is why saya a little bit hairan lah, kenapa soalan trial pada tahun ini kan banyak yang electromagnetic waves because last year SPM 2019, let me just double check now, was sound waves. Yeah. So the question was on sound waves and then dia cakap pasal a concrete wall. So how are you going to design a concrete wall so that the sound from the highway doesn't go into the houses di sebelah? Okay, so it's pretty strange that the trials this year banyak yang focus on wave again. Okay, except that they don't really focus on question number 10, they could focus on question number 12. Okay, but since we are doing this, I thought, okay lah, saya cover sekaligus lah. Because dia interference juga, cuma dia sound wave. Okay, so a little bit strange lah. So I'm not going to talk about this. Okay, this is the same thing lah. So the material of the wall and the floor of the hall. Okay, same question as just now. Okay, the hall question. Okay, so the stage of the school has poor quality of sound used for singing competition. So you are assigned to modify the school hall to be used for the singing competition. Kita mau better quality of sound. Okay, so these three aspects: material of the wall and the floor of the hall. Okay, distance and the location of the two loudspeakers. So one is distance, one is location. So we want the distance to be big, and then the location is high. Okay, we want the location to be high, we want the location to be low. Okay, so what's the question? Is this Terengganu? First one. Okay. Yep. Okay, so the location should be high, so that there's less obstacles. Okay, less barriers, less obstacles. Okay, shape of the surface of the hard wall. Usually for singing, okay, especially, it shouldn't be a flat wall. It should be grooved. Okay, go and look at the black book. Okay, the answers for this are in the black book. Cuma saya mau highlight sajalah bahawa there is an interference question in Terengganu. Majority of the questions this year seem to come from the satellite question. Okay, but because we're covering waves as a topic, okay, so saya rasa kita harus cakap juga pasal ni lah. Okay, so give this question a try. Look for your black book for the answer. This one talks about diffraction. Okay, why is it that only C can hear, but B and A cannot hear? Kalau dia high pitch. Okay, kalau dia low pitch, all three students can hear. Kalau dia punya sound is low. Actually, it's not just diffraction, it's also refraction. Okay, dua konsep tertanya di sini. I'm not sure whether this is in the black book. You know what? I don't think it is. So let me give this to you. Wow, it's so long. Let me see if I have enough space. Okay. I will write it over here lah. Okay. Oh no. Okay. So okay. So over here dia cakap based on V equals to F lambda. Okay, as the speed of sound is constant, the wavelength is inversely proportional, okay, to the frequency. Okay, point number one. Okay. Point number two, high pitch sound. I'm going to cut short this. High pitch sound is high frequency, shorter wavelength. Okay, because wavelength is inversely proportional to high frequency. So high pitch is high frequency. High frequency is shorter wavelength. So just now the question is, when the high pitch sound is generated, only C can hear. Okay, because it's a shorter wavelength. So the next point will be shorter wavelength, okay, results in a less diffraction. Okay, that's why only C can hear. Okay, and then the next point, okay, the next 2 points is the total opposite of this lah. Okay, low pitch sound is low frequency, therefore bigger wavelength. Bigger wavelength means more diffraction. A and B can hear. Okay. 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 Sorry. This one, less diffraction means only C can hear. Yeah. Okay. Then you terbalikkan, the next 2 points kamu terbalikkan. Low pitch sound, low frequency, longer wavelength. Longer wavelength means more diffraction. ABC can hear. Okay. So if this is a high frequency, okay, high frequency kan, sikit saja dia punya diffraction. Okay, so only C can hear. But if it's low frequency, more chance for diffraction, so you will be able to sampai A pun boleh dengar kalau dia low frequency. Okay, all right. So now we come to finally, okay, we come to the experiment questions. Now there are 2 experiments which seem to be very popular in wave, okay, and it is actually experiments that we've talked about. The number 1 popular experiment is found in Kelantan 2020, which is the interference of sound waves. Okay, so in this case of sound waves, so diagram shows 2 workers going to set a closed hall, blah blah blah. Same thing lah. Okay, so state the suitable interference. Okay, kita dapati bahawa when the workers put the 2 speakers closer to each other, the distance between the 2 chairs must be set further apart. Okay, so this is the relationship between A and X. Okay, 2 speakers is A. Okay, distance between the 2 sources. Okay, X is, so this is the MV. Okay, X is the RV, the distance between the 2 antinodal lines, or the distance between the 2 consecutive nodal lines. Okay, so people, this year, I highly suggest interference formula. Don't just hafal the formula, hafal what is AXD. Okay, you need to know what those words are. Okay, otherwise, how are you going to answer this experiment question kalau this experiment yang keluar? Okay, now always double check this one to make sure that you're using loudspeaker and audio signal generator. There has been 1 trial question, not this year, previous years, and I think also an SPM question. Dia bagi situasi macam ni, they give this situation, but the apparatus is not loudspeaker or audio signal tau. They give ripple tank. Ripple tank, yeah. So we have to be very careful. Although the situation looks like it's interference of sound waves, okay, although the situation looks like interference of sound waves, but you have to look at the apparatus and make sure that we are talking about the sound wave experiment. Because if the apparatus is ripple tank, you cannot use audio generator. Okay, you can only use the frequency generator. Okay, which I will show you in a little bit. Okay, so be very careful. Pernah terjadi, situation dia bagi is interference of sound. Tapi apparatus dia bagi bukan loudspeaker. Okay, dia bagi apparatus for normal interference. Okay, yang buat di ripple tank semua itu. Okay, so be very careful with this. Okay, be very, very careful. Okay, another popular question is this one now. Okay, and this occurs 3 times, I think. Yeah, 3 different trial papers have asked the same question. Okay, so take a look at this. Diagram 4 shows, oh, sorry. In case you're asking, I will show you the experiment in a little while. Just let me explain the question first. So the first question yang kita harapkan keluar pada tahun ini is interference of sound waves. Okay, / interference of waves. Okay, you should know both. This is the next one that seems to be very popular this year, which is shallow region, look at the wavelength, deep region, look at the wavelength. Okay, so this seems to be this one between MV is depth and RV is wavelength. Okay, seems to be that lah. Okay, so if you take a look, ripple tank, vibrator motor, you kind of know it is a ripple tank question. Okay, the aim of the experiment is to investigate the relationship between the depth and the wavelength. Yeah, that was the wavelength. Okay. Yeah, that wavelength. sorry. Okay. This is also another situation given by Penang. Okay, movement, sorry. It is observed that the distance between the two adjacent waves, okay, this distance, are far apart at the deep sea. As the moves wave towards the beach, the distance between the two adjacent waves becomes closer. Same thing, depth and wavelength. Same question. Cuma dia punya apparatus is ripple tank glass block. Slightly different. Actually, not that much different now. Also can. Okay. This one is from Perlis. Perlis 2020 gives the exact same situation, except that doesn't give you the observation. Asks you to observe yourself. And the only apparatus they give is ripple tank. Okay. The waves propagate from sea to shore. Kita tengok di sini wavelength besar. Okay, di sini wavelength kecil. So it looks like the same question. MV is depth, kedalaman air, and then the RV, the responding variable, is the wavelength. Okay, so this is how the experiment would be, except that for the wave and for the depth and the wavelength question, you can actually take a look at the SBP 2018 paper 3 question 4. The answer is there. Just go ahead and copy down the answer and use that. This one got no operational definition. Okay, no operational definition, so you don't have to worry. Last week I talked about the operational definition of water pressure bahkan. Okay, so please recall that in this experiment, both experiments, there is no operational definition. Okay, so I'm not going to talk so much about this wave, this one, because the answer is actually here. You should copy this down and put it aside into your last minute paper lah. Means always memorize this experiment after a while. Okay, the interference of sound experiment is a bit different. I know that over here kan saya tulis X A X makan, but guys please it has to be full sentence. You cannot write X depends on A. Okay, so you have to write the distance between two consecutive loud or soft sound depends on the distance between two speakers. Must be in full sentence. This guide that I'm giving you over here, which you can screenshot if you want, okay, because this one is not in your SBP book, sorry. So you can screenshot this so that you can create your own answer scheme, okay, which is the point of all these holiday sessions. Okay, kelamaan kan, I want you to have a stack of papers that have the projected questions lah, soalan yang kita ramalkan mungkin akan keluar pada tahun ini. So that you have these answers kan, tinggal kau baca last minute sahaja. Okay, so make sure that this experiment is also in the list. But don't write short form. Okay, write it in the long form. Okay, so that's why dia bagi ini keyword di sini lah, because it's very long lah. Okay, so yeah, so the MV is A, the RV is X, the we use CV, constant variable. The constant variable is D, the distance between the source, okay, over here, and the sound. Okay, so the procedures are all given here. Take a screenshot of this so that you can write your own answers later. Okay, and yeah, these are the two wave experiments that we are projecting this year to come out. Okay, and this seems to be the more popular one. Okay, with depth and wavelength. But well, those of you who know me, you know that I don't always believe in popular questions. Okay, it may be popular for a reason, but sometimes um, things can change. Okay, if anything that 2020 has taught us is that sometimes we must be ready for the curveball. Okay, so yeah, always prepare more than one. So last week I gave you 2 experiments. This week I'm giving you another 2 experiments. By the end of our holiday sessions, you should have 8 experiments. At least 8 experiments that we are projecting. Tapi 2 saja akan keluar lah kan. Okay, 2 saja akan keluar. But at least you have 8 kan. You know, you have a safety net lah. What if one topic keluar, one topic keluar? Okay, so, and you don't have to answer both. You only answer one, either form 4 or form 5. Okay, so yeah, let's work towards that. Okay, the point of these holiday sessions is so that you can have a stack of notes that you can read right at the very last minute. Okay, that's the point of this, which with all the projected questions. Okay, so I think that's about it for today. Unless you guys have any questions that you want to ask me. I've covered every single question that I want to talk about today, actually, which is pretty amazing. Except for that one question, which looks very weird, right? Okay, I will show you the answers if I can get it lah. Okay, I will show you the answers as soon as I understand what the question is saying. Okay. Okay. Sorry, so we are going back to the question that I left out just now, which is the Negeri Sembilan paper, question number 8. Okay, question number 8. Oh dear, what am I doing? Oh, I'm rubbing this off. Okay, so it's true. The formula that we want to use is actually D equals to VT over 2. Okay, which is the formula that we want to use. Except that this 35,000 kilometers doesn't seem to serve any purpose. Okay, because what we want is the focal length of the disk. I want to know, and see the time they give here, right, is taken by the waves to be reflected back by the disk to the receiver. Means the waves come here and then reflect here. So this distance, okay, is 2 nanoseconds. So bongok. Okay, that distance is actually 2 nanoseconds. So we don't even need this divide by 2. Because divide by 2, we use this formula if we send the signal and bring the signal back. That's why we divide by 2. But since this question is talking about traveling from here to here, okay, from the parabolic dish all the way to the receiver. So the time taken is 2 nanoseconds. Okay, and the velocity of electromagnetic waves is always the same, 3 times 10 to the power of 8. Okay, and therefore this distance is the focal length of the disk. So we will have D equals to 3 times 10 to the power of 8 times 2 nanoseconds, 2 times 10 to the power of negative 9. Okay, and we will get 0.6 meters. So at first glance, when I was looking at this question, I thought, why would they give this 35,000 kilometers for? Like, is it, I mean, my first instinct would be, oh, okay, 35,000 is D. But when you read the question properly, bila kau baca soalan betul-betul kan, jika masa yang diambil oleh gelombang itu dipantulkan semula oleh piring ke penerima isyarat, we're just talking about this distance. The 35,000 kilometers doesn't matter. Okay, so this is, it's an interesting question. It's a hot question maybe. Okay, but it's pretty interesting. Okay, so I hope that this helps you to answer this now. Okay, but if you cannot get these calculation questions, don't worry. Focus on the main stuff. Okay, the main stuff is the 10-mark questions, the experiment questions. That's the big thing that we want to talk about today. Okay, all right. I think if there's no more, um, today is the 30th of December. In 2 more days, we are going to be hitting 2021. And I have never taught a bunch of students that I have never taught a bunch of students for more than 2 years. So congratulations, everybody. You are the first bunch of students in my entire 15 years as a teacher yang saya ajar lebih daripada 2 tahun. Okay, bravo, clap. Okay, but uh, but you know, we'll take it one step at a time. Okay, only 2 more months until this nightmare is over. In the meantime, don't forget now, we don't have any class on Friday. We will resume everything next week. Next week, I will go into it full swing. Monday and Friday at Maths. Wednesday is Physics. Physics, we will cover another topic. At Maths, we will cover 2 different states punya papers. Okay, I will let you all know which states I will cover so that maybe you can use this weekend to revise or to answer the questions in those papers. Okay, in the meantime, have a happy new year everyone. Tolong maafkan segala silap dan salah saya dari hujung rambut yang tiada ke hujung kaki yang masih ada. Okay, yeah, happy new year everyone. Stay safe at home. Don't go out if you don't have to. But I do hope that you have a good New Year's Eve and a good New Year with everyone, okay, in your family. Okay, take care everyone. I will see you. Happy New Year.